Hello everyone, my name is Bhavna Khurana and I take mathematics optional here at Vajiram Ravi. Today I'm going to do a quick overview and analysis of this year's mains 2024 which just concluded recently. Before we go into the overview of what the paper looked like, a few key points. This year specifically, paper 1 section A has come out to be reasonably easy. And by easy, I mean that if you do all the PYQs, then questions are based on exactly the same topics that have been asked in the past. In fact, I would take the liberty to say that it's a bit lopsided. A lot of questions have come from bases, null space, range, and all of them, the background required for them was basically the row reductions. So, for example, if you talk about paper 1 section A, then the topics that they ask are linear algebra, calculus and geometry. All the three. So, linear algebra has come out to be very, very predictable, absolutely on the lines of what previous year question papers have been like. Calculus is also very predictable. Geometry, where there usually sometimes they ask some questions which are offbeat, this year has been pretty much on the lines that they have always been asking. Coming to paper 1 section B, ODE was a bit unconventional. So, which means that they've asked questions, for example, from Laplace combined together in ODE and PD. Laplace has come for about 55 marks. 55 marks from one particular chapter. And that topic, of course, is covered both in ODE and PD, yet on an average, in the past, they have asked questions ranging from 0 to about 15 marks only from there. And if you include PD, then sometimes up to 20 to 25, but not definitely 55. So it was unconventional in that sense. Also, there were some new terminologies that they had introduced. And unlike in the past, when they have used new concepts, they have also defined it. But here, for example, the direct delta function, if they had just given us the definition, everyone would have been in the position to handle it. But they had just left it like that. So it was pretty binary in the sense that if you knew this function, then you can try. If you didn't have any idea, then it could be completely gone. So overall, I would say that means if you look at it in totality, paper 1 section A, like I said, is very simple, of course, provided you have studied the PYQs, you've done the basic concepts. Paper 1 section B, OD has come out to be unconventional. Vectors, 10 marker, which was divided into two 5 mark questions, was pretty lengthy. I mean, for 5 marks, they have also allocated up to 3 pages as per what the students have informed me. And so which means that they're lengthier questions and the allocation of the marks is shrinking. So it was in that way, one question was very lengthy. One question was also a bit, I wouldn't say twisted, but if you don't look at it carefully, then at the look of it, it might just look difficult, but it wasn't really. Otherwise, it was pretty straightforward. One important observation is that the physics topics, which are usually considered to be on the tougher side by the students of mathematics optional, were actually very straightforward, comparatively. There was no new twist to the questions. Questions were pretty straightforward and it was quite doable. So overall, out of the entire syllabus for paper 1, except for ODE, the paper was pretty easy, provided you have had the right approach to study it. Coming to paper 2, section A. Now, the topic that scares the students usually the most, modern algebra, it was very, very direct. I mean, it couldn't have been a simpler paper. Direct questions have been asked from modern algebra, and so it was really simple. Together with this, real analysis has also come out to be very simple. Having said that, real analysis is a huge syllabus. It also sometimes encompasses the calculus portion here. So it's quite huge, and to be able to focus on what exactly can come is a little bit of a challenge. But they haven't asked any question which was not doable. So one question on Riemann has been asked, one question on uniform convergence, which I think a lot of students who are not honors students would struggle with the theorem behind it. But if you sit down and do it like a numerical, it wasn't that tough finally. There was also a question on improper integral. There was a question on Cauchy's convergence criteria. And so they're pretty much on the lines that we expect. Even the limit question that had come, limit or continuity, was pretty simple. Coming to paper 2, section B, PD was again a bit unconventional. Again, like I said, one primary reason for that is that Laplace itself has come for much more marks than they have ever asked in the past. So it can also sort of once when you are in the exam setting, when you look at the question, you really don't have time to analyze the information so much. So one ends up sort of doing only the predictable or the questions that you've seen in the past. So PD a bit unconventional. Physics again, which also includes the fluid part, and again something that students really find tough, has come out to be pretty much direct, except barring one calculation maybe. That also I would like to reiterate that there's a stark difference between your approach to a question which says find the volume or area or something, as compared to show that. So when the question is show that, you any which ways are very sure of the answer. So even if the calculations are becoming not so easy to take it forward, but the final answer is there. So bit of manipulation in between makes your answer very much presentable. Now, one very important thing that can be assessed from here, and that is very, very important, is that I've had a lot of students who crib about a few key topics of your syllabus, like modern algebra, like physics, like analysis. Now, just when the exam are on your head, you have to make a strategic decision. That strategic decision cannot be that you leave one topic completely. For example, I know of at least one student who just towards the end, when the exams are in fact going on, the essay paper has happened, the GS papers have happened, and that small gap that you have, and I was called to ask, and that student specifically said that modern algebra, I don't have time to revise, I'm leaving it out. Now, in contrast, he of course had covered almost everything else. But if you ask me honestly, modern algebra paper was so direct that even if you had just done the basics, just the bare minimum basics, especially of group theory, out of I think 4 questions that have been asked, 3 are from group theory. So no advanced ring theory has been asked. And that's actually been the trend for the last 3, 4, 5 years. They haven't asked any complicated question from either Euclidean domain or PID or Eisenstein's criteria. They have always asked questions only in ring theory till ideals. And in group theory, they are asking questions up to only Lagrange's or homomorphism. So I would say that if group theory, ring theory was divided into layers, say there is basic group theory, advanced group theory, ring theory and advanced ring theory. All the questions that have come from basic group theory, 75% of them. And one is from basic ring theory. So it was very, very doable. And in contrast, people usually OD and PD they find easier this year, like I said. So you can't take a decision of leaving out a chunk. More important reason of making this video is, of course, discussing what has happened, but that's like in hindsight and retrospectively. The way forward for students who are watching me right now is that all the 13 topics are important. You cannot leave any topic. The next question students generally ask, but ma'am, syllabus is huge, and the humongous syllabus, if you cover also once, to be able to revise it with that much depth always is a challenge. For that, I would like to tell you that out of all the 13 topics that you have, you must divide after once your preparation is done. Suppose you've covered the syllabus at least once. You divide the topics, and this is the analysis that will help you look at way forward. That some topics you should really be pro at. Basically, you should have sort of mastery over it. The other ones you are basically at average level, like about 60-70% of the questions from the PYQs you're able to do yourself, rest you need help. And these are the ones which you find tougher. Now, even if I look at 13 topics as the syllabus, what you have to master is definitely about 3 to 4. That's all I'm asking you to do. And the tougher topics are also about 3. Okay? That leaves us with the other topics which are all going to be about average. But do not do the mistake of leaving out anything, because sometimes from the topics that you think are tougher, simplest of questions can come. Whereas topics that you think you have mastered, a question can come which completely stumps you. So instead of focusing and deep diving into just one topic completely, do everything at an average level. Some of the topics you prepare very, very well, which means almost all PYQs you are able to handle. And if you're writing tests, you're able to do everything from that. And some topics you are going to call as difficult ones, but the difficult topics, do all the basics ones at least, based on the PYQs. At least do, for example, from physics to very roughly say, you must always do questions based on streamlines. It's hardly physics, it is actually differential equations. Yeah? Modern algebra, you must cover Lagrange's theorem, you must cover homomorphism. Ring theory, you must cover till ideals, and again homomorphism in that also. So some basic topics that have been repeated in the past must be on your fingertip before you go in for the exam next year. Now, I would take my discussion forward, and this is a very overview kind of a thing. We'll be actually posting this PDF together with the physics PDF on the website for you to have a detailed look. But I want to explain a few points while I breeze through the questions. So we're not really solving the paper, we're just discussing what kind of questions. For example, paper 1, question number 1B, and I hope you can read, is that T is a mapping from R cube to R cube and it's a linear operator. First of all, a student must be aware of the fact that there are linear transformations, then there are linear operators, and the third word is linear functionals. The advantage of something being a linear operator is that if you, for example, want to show something is invertible, then you have to either show 1, 1 or you have to show onto. So small remarks like these can help you do the question in the space that has been allocated and proportional to the marks that are allocated to that question. So this is basically 1B, which means it's a compulsory but a 10-mark question. 10 marks only. And what does the question say? It says that find a basis for the range also and for the null space also. So clearly, like I say all the time in the class, that your presentation has to be done as far as possible in steps. Bare minimum steps in any question has to be 3. First has to be the introduction, which means what are you beginning with, how is it given, B is given to be V1, V2, V3. It's already given to be a basis. Now T is given to be an operator which behaves like that. So introduction sometimes in a numerical question can just be what all is given in the question. Question is of course framed using English language or Hindi for that matter, but you have to write the mathematical takeaway from there. What in a sense is the given information. So if I were you, then I would write the introduction as T is given to be a mapping from R cube to R cube such that T of V1, so just copy down the information but without the extra words that it's a linear operator. You can write down the word linear transformation on top or linear operator on top. So basically just the given question written in the format of given. This is your introduction. Then the main body of your solution in our question has to be divided into 2 parts. First, you have to find the basis of the range space, and second, that of the null space. I would strongly urge you to use dimension theorem after finding one of them nicely and properly. In the exam, you can't your concentration level cannot be at its peak at every given minute of the exam. So you have to give your brain a little bit of rest, and that is very possible in maths because you find range space thoroughly, like double check your calculations and all. Use dimension theorem that immediately tells you what the number of elements is going to be in the basis of the null space. So whenever you know that, show that there are 5 elements here, show that this is the answer, then one strong conviction that of course we all have is that the answer has to come out to be what is given. So even though it's not directly written, but if you just find the range and mentally apply dimension theorem, you already know how many elements in the null space. So that surety of knowing the answer gives you the confidence to move ahead. Second observation for this question is, now there can be several ways of finding the range, So there can be many ways of finding the range. One can do ab initio. Ab initio basically means you apply the basic definition and write down what it's. Then every question will have to be tackled differently. The best way forward is to use the formula that RT is the span of T beta. Also, beta was given to us, which is the basis, and so it would have been far more easier and it would have been much shorter to express it as span of TV1, TV2, dot 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 till TVN, which is 3 in our case, and then identify if they're linearly independent or not because they're already being spanned. So this formula, which is a very basic formula, and as you can see, these are the snapshots of what I have added from the notes or the booklets that Vajiram gives here for maths. And so what we do here is apply this formula so that you can actually get the answer in the most judicious way possible. Idea is not just to get an answer. It has to be time saving. It has to be presentable, right? Together with, of course, accuracy. So all of that is going to be attained if you apply the formula rather than going all over and doing it each question in a separate sort of a manner. Then after that, like I said, orally at least you apply the dimension theorem, so you would know what nullity or the dimension of null space will be, and then you can find out the basis of this particular thing. So I would say this question was pretty straightforward. And like I said, it's not just this one question, but there is an entire collection of such similar questions in the booklet. Because these questions almost every year have been asked in UPSC. Now, another point that I would like to make here is, if a question is predictable or easy, then it's predictable and easy for everyone who's writing the exam. The evaluation in such questions is more stringent. The examiner is not just looking for an answer, but he or she is also looking for how you have attained the answer. That means presentation is going to play a paramount role here in you getting full 10 on 10. I always say in the class also that instead of running over and trying to do every question and not one question up to the standard, it's better to stick to the questions you know in the exam and do them fully from start till end. It has to flow. And the flow will happen if you write down the introduction, you write down the main body. Like in this question, when I was saying, there'll be two parts to it. One is the range, one is the null space. And conclusion is, of course, that we found the basis for both of them as above. So not every question has to necessarily have a conclusion. It is not a humanities-based paper. We're doing a technical bit. But still your answer has to be in blocks. A very common question I get from students is there step marking in the paper? Because obviously after writing the exam, now they have come out, now they're comparing their answers. And they're like, I've done this much correct, but the remaining has gone wrong. So will I get marks for steps? My answer to those people is yes, provided your answer is in steps. You cannot write down an entire paragraph and expect the examiner to give you marks for steps. So step marking is there, provided you write in steps. Which means if you've written step number 1, let us find the basis of the range space, and you've got it correct, the examiner would put a tick mark and he'll have to award you marks for that. Even if you make a mistake, say in the second one, then also he'll have to give you marks. But what do students usually do? A typical answer sheet has no beginning, has no body, it does not have any steps. You just write down range or something and then you write down, then even if one is correct, one is wrong, examiner will not be able to distinguish between the two. So please remember, like I said, if the question seems to be easy, it is easy for everyone. So presentation makes all the more difference. Honestly, in the exam, a person sitting in the exam atmosphere is not thinking about others. There's hardly any time to think. But what is the takeaway from that? That whichever questions you know, you do them so well that nobody can cut even half a mark in that. Rather than running after questions which you don't know. Because in that, even if you struggle, if you have time, of course, we learn all these tricks to how to attempt a paper at least that much that you can steal some marks. But the bulk of the marks that you get will be from the questions that you know fully. Don't mess them up with regards to, compared to the questions that you don't know, So that's the takeaway from here. And from all the other questions that I'm showing you. For example, question number 1C was calculus, very simple, e to the power minus 1 by x. Everybody has to know the left and the right concepts of. So look at how in the notes, the review is written. review is basically you should know these basic 4-5 things, and then any question based on it. Like this one is in fact a tad more complicated than what they have asked. But can you see the format? So in maths, what you can expect is the same concept coming in the exam. The same numerical, we will any which ways not remember the words, no, we will not remember the symbols, 4, 3, 2, e to the power minus 1 by x. If you know the concept, then no matter what question comes, you should be able to do it. Another thing that strikes me from here is it's so important to categorize the questions. Because if someone cannot relate to a question bank kind of a thing, maybe 5 to 10 questions for each topic if you have them somewhere together, only then have you learned that these kind of questions can be handled like this. So in the classes, what do? We look at the review first, which is the basic concept behind the question that we are doing. Then we do one question, then we do one more question, and then some questions will be written in, say, the assignment. So this one, say, is directly from the notes, but similar questions will be added as assignments. Then you do the PYQs, but learn how to categorize the questions. If you identify that this is this type of a question, then the same concept will be applied here and you will be smoothly able to get the answer. Question number 2A, again linear algebra, and again they are talking about C invertible, what my comments were in the first question. Again it is a linear operator. Look at how lopsided it is, because given the entire syllabus, they've not asked linear transformations in general, they've asked linear operator. Again they're asking invertible. So it's about 1, 1 and on 2. And if yes, justify your answer, find T inverse. Very ordinary standard question. Again, T is given here. You can see it can be defined in any one of the ways. The key point here, how do we recognize in the class what we're doing? We're doing operator kind of questions where the definition of the operator is given algebraically. Whether it is a 3x and a x minus y, or it is a 2x and a 4x minus y. Can you see the similarity? So if a student has done this question and with logic, and if you know how to present your answer, there is no way that you'll not get full 15 on 15 in this. So again, a very direct question, I would say. This question again from calculus is a concept that they've asked in the past regarding the Jacobian, used very, very frequently in vector calculus. Now a lot of students ask me, but ma'am, this question has come in section A, and you are referring to Jacobian, which is vector calculus. Remember, calculus is paper 1 section A, vectors is paper 1 section B, but vectors can be categorized as calculus also and analysis also. The placement of this topic in the syllabus is not necessarily important. When you study them together. So in my classes, for example, once we do real analysis and calculus, we jump to vector calculus, because as you can see, vector is analysis and calculus both. You have concepts of limit, continuity, differentiability in vectors. You also have a lot of calculus, like I said, the Jacobian, the calculation part of the analysis. So the syllabus is pretty beautifully interlinked. And if a student can appreciate that, then the humongous syllabus does not really look overwhelming. It is seriously within our control if you know how to make connections. Now this question again, I would say, is pretty special because everyone ends up revising questions based on algebraic definitions. And look at what the definition is. For example, let's look at the question from the assignment here in the booklet. Let T be a linear operator again. Have they given a linear operator here also? Yes, because it's again V to V. So 3 questions, all of them are linear operators. And on M2C defined as TA is BA, where B is defined to be this matrix. What does that mean? When T is applied to a matrix, the answer is that matrix being multiplied with A. Look at this. Look at the definition. The same question. And they're saying, hence find the rank, is it invertible, and justify your answer. So justify. Now this is also one thing that I've realized, that maths people we got the answer. Now we don't want to justify anything. In a GS question, if they ask justify something, you go on and write about 150 words to justify. Here I understand primarily we're going to do calculations, 90% of it. But at least devote your 10% of the solution to justify, because it's being asked as a separate compartmentalized kind of a question. So very simple, very straightforward question. In fact, the assignment question is one notch higher only than the level that they have asked. So pretty basic question, I would say. But people would have been overwhelmed because it is matrix being multiplied. So they don't usually... Now, this question from calculus, find the volume of the greatest cylinder, which can be inscribed in a cone. So cylinder and inscribed in a cone. Look at the question from the booklets now. Volume of the largest rectangular parallelopiped that can be inscribed in an ellipsoid. So basically, what is the category that I was mentioning earlier? Learn how to categorize questions on the basis of volume of this inscribed in this. There is a standard approach to such questions. It's basically a maxima minima application. Yeah. So if you know one question, the other one in the exam, and it's very straightforward, this question also, and it's worth 20 marks. I think anybody who knows how to do basic calculus should be able to do this particular question. Again, a geometry question. Find the vertex of the cone. Now, vertex of the cone, as you can see here, if fx, y, z represents a cone, the coordinates of its vertex satisfy the equations fx, which is a partial derivative of f with respect to x, partial derivative of f with respect to y, partial derivative of f with respect to z, and f with respect to t put equal to 0. Any person right now who has basic information regarding the maths syllabus can also just read it from here without any idea of what a cone is and how to do it, can get the answer for this. So you're basically going to call this entire expression that's given as f of x, y, z equal to 0. And where t is used to make this as homogeneous. So you check whether so you can see till here everything is of degree 2. And here you have linear terms and here you have a constant also. So to make it homogeneous basically means just introduce a variable called t here, a variable called t here, a variable called t here, and a t square here. What has happened? The function has become homogeneous of degree 2. And then so it's really just this line. And again, this is to try and show you that how the basics of all the questions that have been asked can be covered through the class notes. Even though math syllabus, one can do books after books after books to get what people call as practice. But practicing in a directionless manner is not going to help you finally in the exam. Yes, practice is important, but you have to practice knowing, first of all, it's the concept. Then the recognition, oh, this question is this type. That happens how? When you learn how to categorize the questions. And at least in my classes, what we focus more on is the category. This problem can be, so procedure is important, but students, if you can't recognize only how this question has to be tackled, the procedure is not going to help you. First, the recognition, which is based on categorization. So it's very important to know how to cover the entire syllabus through bits and pieces. Again, a linear algebra question. Very straightforward again. They haven't even touched diagonalizability. They have only talked about getting they are only talking about getting the eigenvalues. Now, I remember making this remark. It's the screenshots added are just from the booklet, but there are many questions even from the test series that was conducted. And I remember making a remark because a similar question I'd given in the test paper. And I think I'd asked, find the eigenvalues of a to the power 5. Yeah. What the student has done is, because A is a given matrix, he has done A into A, you get another square matrix. Then he calculated A cube. He's showing me the calculations also. Now, it's not that you can't do this. But my remark to that person while evaluating and giving a personal feedback was that what if, in fact, I'd written that, what if it was A to the power 15? So really a deja vu feeling here, that you can't do it like because the question you cannot do it endlessly. A to the power 15 to calculate it, even if you use your scientific calculator, it would take you some amount of time. And please understand the objective of the examiner asking this question. He's not asking you to do these calculations which a class 12th student can also do. Multiplying matrices is not a level of the question that is being asked. What are they asking? Number one, they're saying find the eigenvalues and eigenvectors of A. This is pretty standard. Hence find Hence, also the word hence does not mean find a to the power 5 as a separate matrix, call it as B and now find. No, hence means from the previous part. So what am I focusing on? I'm focusing on the fact that if lambda is an eigenvalue of A, then lambda to the power K is going to be an eigenvalue of A to the power of K. Please prove this result as a lemma. What is a lemma? A supporting theorem, a backbone or the skeleton of how you are performing the calculations is called a lemma. It can either be written right in the beginning or you use it comfortably, and if time allows and if there's no paucity of space, then you can also prove them. Definitely state them, and if other factors are in your favor, like you have time, you have space, and so then you can also prove them, but minimum you have to state these lemmas. So this is what you have to really concentrate on, because please remember again, I classify this question as an easy question. So if everyone is going to do it, in fact they've asked a to the power minus 15 by the way. So it's a to the power 15 and the inverse of it. So you can actually prove it this for even k negative, right? And so it's very important to pay attention to how you're presenting your answers, otherwise you're not going to get marks. Use, this is again calculus, using double integration, again a topic which comes in vector calculus also and calculus also. Find the area lying inside the cardioid. So you need to know the basic shape of a cardioid. Cardioid comes from cardiac, which is a heart-shaped curve that you have. And as you can see in the notes, we have solved this question where we are evaluating this area and cardioid is given to be like this. So here you have to find the area inside the cardioid itself and outside the circle. So basically a circle is given to us and you have to find out the area. Very, very standard question. You can do it by standard substitutions. And so, you know, like this, and then you have to find the area inside the cardioid and outside the circle. So it could be like this kind of a thing, inside the cardioid, outside the circle. So it can be vice versa. So you have to learn how to make the shape, identify the region that they're asking us to do, and then work on the limits. So double limits will be, and then you'll be able to do this question. So again, pretty standard question. In fact, a lot of students remember the answers also. Orthogonal trajectories. Again, we have solved a question on a cardioid. The previous question was also a cardioid, but this one is r is equal to a1 minus cos theta. This one is r is equal to c sec theta plus tan theta. So it's the same question, because like I said, we can't predict what numerical will come. But now look at the presentation here. Can you see step 1, then step 2, then step 3 and so on and so forth. If you learn how to present your answers in steps, there is no way that you're not going to get the maximum marks allocated to that question. And that should be the objective of any student who has taken mathematics as their optional. Please do not treat this as any of the humanities paper or your general studies where you're told that you don't get more than 6, 7 out of 10. Here you do get a full 10 on 10. But it's also binary. If one question comes which you absolutely have no idea of, then you have to leave it completely. But the remaining questions do help you get full marks. It's very much possible. But I wouldn't say, I mean, till a few years ago, I used to say it's also very easy to get full marks, isn't it? But that was wrong on my part, because one, I've seen students have not developed the art of presenting their answers. It's like this, if you know it, but you can't present. What's the point? So if you know it, you have to learn how to present your answers in steps. Only then can an examiner also see what you have written, no? So you have to force the examiner to give you marks. Let's come to 5B. Again, this is Laplace transform, which is lopsided this year. Lot of Laplace questions have come, and this was an application of something called the convolution theorem. But it wasn't very direct. I don't think it was a compulsory question. And this is a question I was referring to in the beginning of the talk, that at the look of it, it looks pretty scary. But if you apply scalar triple product and if you know the geometrical representation, then you know that it's the volume. In fact, what they've asked, I think, is the area, if I'm not. Yeah. See, vectorial area. So first they're asking area and then they're asking volume. So very basic question actually. But yeah, it was framed in such a way that it seemed a bit complicated. Question number 6C is about ux is minus e to the power minus x as one of the solutions. In fact, if you compare See, given that, so this is where part of complementary function is known, because if you notice, and I tell my students always to be cautious of recognizing and writing down which kind of a differential equation has been presented to them. So this one is basically because I can see a y double dash, so higher order differential equation but linear and one with variable coefficients. And we are solving, and it's not Euler's, it's linear, higher order variable coefficients but not Euler's. Can be solved by several methods. One of them is when part of a solution is given. And the beauty of this question, of course, like I said, is it is homogeneous because right hand side is 0. So this is where commonly we call this method as part of CF is known. And that part can be anything, like in the question that I gave them in the assignment, it's x plus 1 by x. The question probably we solved will have x squared, it can have log x, it can have e to the power x, any one of them. The procedure, very straightforward question, I would say. Also for 10 marks, but very straightforward. Find the general solution of the differential equation by the method of, again, variation of parameters, the favorite question of the examiners last so many years. Almost every year there's a question on VOP. So you have to be very, very clear about the procedure. And as you can see, if you do some questions nicely, properly, so that you get a hang of what the procedure is, then no matter what question they ask here, recognize and follow the procedure. Again, I hope you can see that I've written the answer in steps, which is how you can get full marks in any question that you're attempting. Stokes theorem question has come verbatim, x, y, i, y, z, j, x, z, k, but that's only it's serendipity. It is not supposed to always be like that. In fact, this one is really matching 100%. I don't think even I realized that. Yeah, it's exactly the same. So again, the question is not about exact question can be pinpoint, but the category of the question. So oriented upwards, can you see in brackets? And they also say upwardly oriented. So, and if you can see here, this is like question number 8. Usually in my booklets, I try to write question number 1 of one type, 2 of another type, 3 of two. So holistically, if someone, so there's lack of time towards the end of the preparation journey, because even between prelims and mains, there's going to be a very small, short gap, and you have to study so much at that time. You need notes which can help you revise everything thoroughly. Of course, you have to have shorter notes from there and so on and so forth. But you don't have to necessarily do 100 questions of each type. But recognition of the question so that you can actually do it better. This is a question that I spoke about in the beginning, that Dirac delta function. If someone, and UPSC, strangely, till about 5 years ago, they used to ask new things, but whatever new was coming, they were also defining it. Now this I saw even when we were studying, say, in IIT, because people all over the country would come and sit there. So somebody's from some university, somebody's from some another university. Terminology cannot be common, right? If you follow a different book, it's a different terminology. So the answer had to cater to no matter what terminology you follow. So if a new function was being defined, till about 5 years ago in UPSC papers I've analyzed, they used to define what it means in the question, which was a good, smart thing to do. Now, for example, 2021, I think they've asked some question on magic square. Now, magic square is not a mathematical term that a mathematician is supposed to know. It's actually some fun puzzle kind of a game. They should have defined what they mean by magic square. Similarly, I feel that they should have defined what a Dirac delta function is for a person, because it's not as obvious as say Kronecker delta. Kronecker delta still everyone kind of has to know, or step function, or exponential function, or log function. There's so many functions we all know, sine function, cos function, but we're not supposed to know Dirac delta as such, So that was the part that was kind of, otherwise solving it by Laplace and doing an IVP through that is an important application. But yet I still classify this question as, people who know it, knew it, but people who didn't have any idea would kind of struggle with. This is Gauss divergence theorem over a conical region. This is over a cylindrical region. And well, for us actually, cones and cylinders are not that different, because as mathematicians, we just look at the base that's given, right? So this is a cone because it has like a vertex kind of a thing. And this will be like a cylinder. Yeah. So we actually work with the base usually. So if you see this, you'll know why it is actually pretty much a similar kind of a question. And so this was also very direct. Expected Gauss divergence theorem was expected. And then there were other questions. So this, along with the physics of paper 1, is pretty much directly from the notes, the concepts, from the notes, from the assignment. So if someone comprehensively covers it nicely and properly, it wasn't an unexpected paper. Coming to paper 2, it's considered to be the tougher out of the two papers, primarily because of 3 reasons: modern algebra, real analysis, and fluid of the physics. Now, like I said earlier in the beginning of my discussion, modern algebra is the queen of mathematics. Maths is queen of science. And algebra, modern algebra specifically, is the queen of maths. You have to give its due importance. Now, students don't appreciate it, so let me take a minute to explain. By doing modern algebra, you are not just studying a particular topic which comes to about 40 to 50 marks in the exam. You're also getting an insight into why maths or how maths is so super logical. The analytical abilities start developing if you do algebra well. Your writing skills grow exponentially if you learn how to write down the proof of the theorems. Yes, you can write down the proof of the theorems yourself, of course. Theorems are not to be crammed. What is a theorem? It is a step-by-step logical way of moving from what is given and what you want to achieve. It's a bridge you make between it. The answer has to come from what is given and you have to reach till what you have to show. One after the other, you have to apply a repetitive sequence of logical steps. So your logical abilities also become sharper. These are the advantages, isn't it, of taking maths as an optional? Yeah, logical abilities get developed, and vice versa. If you have logical abilities, and maths is the optional for you, because there's absolutely no cramming in modern algebra, yet because of basic fear, and I honestly don't know why. Not of everyone, of course, but like I said, if some students actually get a hang of it, then they start doing this over other calculations. You know, some of them write beautifully. So this question specifically, I would like to draw your attention to. Let's see what the difference is between the question that's come in the exam is about M and N, and the question we solved is about P and Q. Otherwise, it's exactly the same. Can you see M greater than N, P greater than Q? I mean, like I said, it's very, 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 and show that G has at most one subgroup. G has at most one subgroup. So it's verbatim. One more thing I'll show you. Like I've written here, like in question 2, which means it's not the only question that we solve now in the booklet. We solve similar questions. The idea is to do clubbing, categorizing, like I've said in the past. So this question was very direct. Question number 1C. Again, very direct. Real analysis, improper integral. Writing is very, very important. As you can see, log-based questions. So many of them we cover in the class. And this was based on LCT, I think. So you could take 1 upon under root 2 minus x as your function and then proceed. This was a question from complex numbers. I would say pretty easy. Not difficult at all. Cauchy's general principle of convergence. Now again, something that an honors student studies in depth. Usually others like engineers and people who are from other backgrounds look at it from a overview point of view. But otherwise, and in fact, this exact same question is solved in the notes. Exact same question. It's a very classic question. Very, very classic question. You will find it being reflected in a lot of exam papers. But we could solve it directly also. We could check the convergence of it directly, ab initio, or we could apply the Cauchy's convergence criteria. So using Cauchy's general principle of convergence, which is actually, and they've asked, in fact today I was evaluating some script of the real and calculus test, and there was a question on define what is a Cauchy sequence. Then tell me what is a Cauchy convergence criteria. So do not skip the theorems, no? Like this could cost you heavy, it's 15 marks. Don't skip the basics. In fact, concentrate on the theorems. Again, show that every homomorphic image of an abelian group is abelian, but the converse is not necessarily true. Verbatim, a homomorphic image of an abelian subgroup is also an abelian subgroup, and those who are wondering, group is also a subgroup, by the way. So what they have asked is a direct application of this question. And very small, look at the length of this question, and of course you have to give a counter example, but 15 marks, No scope of calculation errors, which is very much a possibility given the exam atmosphere. Careless mistakes tend to happen. So the advantages of doing a theorem is you can't go wrong in the calculations. There's no something called silly errors. You can't do them in a theorem. So do not skip the theorems. In analysis and algebra, you have to concentrate on 20 to 30% of theorems. This year, linear algebra, they've not asked a theorem, but they can. Again, calculating the residue, it's something that a student does at length. This is a question that I was referring to. I would say this is one of the tougher questions I have asked because it is on uniform convergence and differentiation. Now look at, it's not even something that has ever come in the exam in the past, but because I believe in teaching the subject to the level that it demands or the respect that it demands. You can't just focus on PYQs also. You have to be futuristic and think about what can come. Rather, I would say that I think about what is it that would do justice to this topic. If someone says that I know uniform convergence, then what all should you know? Should you just know MN test? Should you just know Weierstrass test? No. First and foremost, you should know why uniform convergence is superior than convergence. What is the difference between the two? And the difference primarily is what you can do with uniform convergence, you can't do if it was only ordinary. The theorem that I've quoted, and it's from the notes again, is uniform convergence and differentiation. You want to differentiate something term by term by term. An ordinary student sitting here, anybody who's sitting here, and I ask you to differentiate this term by term, without blinking an eye, you would say e to the power x and differentiate each one of them. The derivative of 1 will be 0, the derivative of x will be 1, the derivative of this will be x. So you get the same thing. The derivative of this will just come out to be the same thing. It's from calculus point of view, there's nothing wrong. But who allowed you to differentiate an infinite series term by term? We know what is d by dx of f plus g. It is d by dx of f plus d by dx of g. So this can be extended to 3, it can be extended to n. But I hope all of you know that things cannot be extended to infinity without compromising on something. And so when you take it to infinity, you can't always differentiate term by term. You can differentiate only when there's uniform convergence. And we've written the theorem where you can show that, see, the fn dash converges uniformly, converges pointwise, and what is the behavior. And so similar kind of way. You can see at least the algebraic term pretty much matching with it. But I think in general, students would have found this question a bit on the tougher side if you handle it theoretically. However, I've also seen a few people who take it as a numerical, so they can extend it and they can show that term by term. They take it for granted actually that it can be differentiated term by term without going into the why of it. And then they apply that, show that it does not converge uniform. So at least a part of it was from uniform convergence and was direct. But overall, this question was pretty nice. All right, let's move ahead. So LPP, I think duality principle, last 3-4 years continuously being asked. Duality basically means you write down the dual and then solve the dual. Very basic question. This again, ring theory. Remember I was telling you about how ring theory, a direct question has been asked. So you can see if F is a field, then bracket X is a maximal ideal. And before this, we've said if R is a CRU, then Rx upon bracket X is isomorphic to R. So if you do it for any R which is a CRU and somebody just knows that set of integers is a CRU, commutative ring with unity, you can apply the same result to this, isn't it? Zx upon bracket X. And then apply the connection between prime maximal ideals and field and integral domains to get an answer. So again, very basic question, provided you had time to revise rings. If someone decides to leave it completely, then it's going to be catastrophic. Let's see 4B, again Riemann question, very nice, and it's a very, so basically rational and irrational define, we are remembering Dirichlet's function here. The Dirichlet's function is a typical function which is not integrable actually. So, and it divides itself into over the rationals and irrationals. This question was also pretty much the same. And you had to actually here show that it's not integrable. So you had to actually calculate the, UPF and the LPF here. So we'll calculate the upper sum and calculate the lower sum and show that they are not equal to each other. In fact, the infimum of the UPF is not equal to the supremum of the LPF, but the steps would be again a question which should be presented only in steps. So even if you sort of make a mistake towards the end, even if you do that, though after a while it's impossible because the major chunk is calculating UPF and LPF. And so, but if you write it in steps, it will be very beautifully presented. Question number 4C is an assignment problem, 20 marks, and it's a case of an unbalanced assignment problem. Now again, if people have not identified that it's unbalanced, it is going to cost you very, very heavy. So this is, I always tell people, and my students who are listening would vouch for it. I tell you, don't I, that I always try and understand what the size is of the matrix. So this is 3 rows and 4 columns. If you had taken the trouble of writing that down, and if you knew that for assignment problem we follow something called Hungarian method, and the first step in Hungarian method is that the problem must be balanced, by which we mean it can only be applied to a n cross n matrix. So basically I call it a step 0. Before you start doing the question here, you would have to introduce a dummy row with all the costs as 0, and then only you can proceed. Even if, by chance in this question actually the cost is coming out to be the optimal cost without adding, that just by fluke, it's coincidence. But you're not going to get any marks for doing that, by the way, okay? So you have to be very, very careful about these small, very basic question. Gauss-Jordan again has been plenty of questions we do in the class. This was also an interesting question. It's quasi-linear, so PP plus QQ equal to R. But there was some extra data given. It's very interesting how some students have been able to tackle because some information is matching, but there is, so you apply that also. In fact, this resembles the answers you will get from here. So it's a very interesting question, not difficult, but yes, on the spot in the exam, I don't know. This again, this is numerical analysis, Simpsons and trapezoidal. In the notes, trapezoidal and Simpsons. So it's of course something that was very much on the expected lines. Newton's forward difference formula, again, a very, very direct question from here. I think it's one of the questions in the test series. So with this, we come to an end of overview or a total assessment of what the paper is. This together with physics in both the papers. Again, a similar kind of a thing for physics also. How the questions have been reflected from the booklets that we give here and how they're discussed in the class, not on the basis of this is definitely coming in the exam, but this category can be represented in the exam. So learn how to categorize, and I hope together with accuracy, students will always be now focusing on the presentation, which is paramount, because you can't just write down an answer and expect full marks. The advantage of taking maths was that you can get higher scores allocated to each question. You have to not do a sort of a mediocre job with every question. Every question that you attempt has to be fully attempted with lemmas, with theorems, with definitions, with diagrams if required, so that even if there are 1 or 2 questions that you kind of can't handle, you can still safely sail through, right? So given the level that paper was, I think it's safe to assume that a student, someone who studied well, someone who's put in the right amount of effort that is required, can score 300 plus in this paper. And that is a wonderful score to get in your optional. So I wish you all the best, and I hope this overall assessment of the paper was helpful in you also making an analysis of what the paper is like. Identify your strengths and weaknesses, work on your weaknesses, but don't forget to work on your strengths also. That's very, very important. Thank you.